Thank you. It's so good to see all of you. I see a lot of familiar faces in the crowd, and welcome to the new ones. I just want to, before we begin, I want to get a show of hands. Anyone who is currently employed at IKEA? Okay. All right, we're good. Okay. So IKEA, for those who aren't acquainted, is a furniture and homeware store. But last year they released this thing. It's called the Obergronsand, and it's unlike anything they've released before. This is what it looks like. So we got some kind of lamp frame thing. It's got pixels. It lights up. Looks pretty baller. Like, I'm a big fan of a minimal aesthetic. You know, I love some graphic, generative art. I was like, this thing is up my alley. So you can definitely say I was intrigued. Here's the website. So, you know, a couple of things to point out. This is limited edition. That's how you know it's good. We got 149 price point. This thing is premium. 0 reviews. Yeah, they'll come. We got, create your own light show. 5 different lighting programs, designed in collaboration with Swedish House Mafia. Now that is an EDM DJ group, so this thing is insane, all right? Of course, I bought one. This is IKEA employees celebrating their first sale. I don't know if anyone else bought this in Perth. It did go out of stock for a while, so I think they sold a few. But as soon as I got it into my house, turned it on. Mild sensitivity warning, okay. This is some of the default animations. They are loud. Like, I don't know if you want this thing in your living room or like a nightclub, but especially in the backgrounds of my team's videos is very distracting, okay? So there's a couple of issues. Can't exactly have it just anywhere around your house. So I dropped $149 on this thing. How do I justify my purchase, right? Like, what are we gonna do to recoup the value, and make me not feel so bad about my purchase? Okay, so I didn't buy this out of nowhere. I have plans, all right? First goal, we want to make this into a piece of functional decorative lighting. Right now it's too loud. Like, it's going to be just flashbanging anyone that comes into the room. All right, and then we want to learn about embedded and graphics. So these are 2 kind of interest areas that I'm bringing together. Perfect project for this kind of thing. Maybe give a tech conference. That definitely wasn't on my agenda when I bought this, but here we are. So we'll see how the other 2 turned out. But before we get started, I want to give a word from our sponsors. Thanks. All right, so I'll be going through a bunch of different areas. This is like a really mixed bag. So if you're interested in like the electronics, the hardware, or the art side of things, or even the cutting edge technology, we got something for everyone. All right, but first, hardware. So how do we hack this thing open? First thing, we're going to access the internals. Next, we got the existing microcontroller has to go. Those five animations, you're never going to see them again, okay? And then we got adding our own microcontroller. We want to be able to program this, do all kinds of fancy tech, so we got to add something a little bit more powerful, a little bit more interesting. And just rewrite all the drivers and application code. Don't worry about it. Easy. And make sure you don't use any guides or help, because this is a learning project, and everyone knows you can't learn if you get help. That's a terrible idea. Don't do that. Get all the help you can. So I wasn't even the first person to have this idea, right? I saw this online. This guy, his name is Fip. He made an entire repository that does essentially what I'm doing. Only problem, it's C++, so I didn't want to use that. Okay. But seriously, shout out to this guy. He has step-by-step instructions on the breakdown and a lot of interesting features, like he has a web portal that you can draw stuff in. Okay, so first step, break into this Fort Knox. This thing is made with metal rivets and thick plastic. So I don't think they wanted anyone to do this, but we're too far in now. We got to use some kind of tool, all right? So get a crowbar, get some pliers, whatever you need. Don't cut yourself. I did. I cut myself on this plastic. It was terrible, but without a bit of blood and sweat, what are you gonna do? And then we're in, okay? So this is kind of a look inside the machine. It's very spooky at the moment, but I'm going to be breaking it down. So this is what we've got. Okay, 4 modules. They're pretty much identical, except the top one has the existing microcontroller. We got some inputs and outputs for each board, so they connect to each other and pass signals down in a row. For each board, we have 4 16-bit registers. So that's going to be what's holding your pixel values, allowing you to write values into this thing and have it display. And then, as I said, we've got the existing microcontroller. Get that out of here. Okay, if you have a desoldering tool, like I don't, then use that. But I use some pliers. This thing was mangled. So get it out of here. It's pretty much a crater where it was, and then you can link your new microcontroller up to the top, and it will act as like a top board controlling all the other ones. This is where you're going to be plugging in your microcontroller pins. So what we got? First thing, VCC. This is like your power connection. This is where power is coming from the wall into your microcontroller. We got CLA. This is like a latch. This is what is going to be used to display things once you're ready to show them on the screen. We got clock D. This is Swedish for clock, I assume. You can push pixels, and that's you use it to read values from your input, which is in. That one's pretty self-explanatory. Is the pixel on or off? And then we got enable. This thing screwed me over. Make sure it's low, otherwise nothing will show up to the screen. I'm assuming this is how they turned it on and off through the button, but I'm not using it. And then we got ground. So that's the opposite to power. You connect it in a circuit. Cool. This is what the final product kind of looks like. We've got our pins. This is breadboard stuff. I'm not doing any kind of custom PCB. This is my microcontroller of choice. This is the ESP32. Very nice microcontroller. So it is Wi-Fi enabled. You got a lot of peripheral connections. It's pretty good tooling, pretty good support. Highly recommend. It's about $30, so I got 2 of them. And then we also have a button. So if you want to add that functionality, there is a button over here, so you can use that. All right. We've got everything wired up. Now we can start writing code. So, Toit. I've been wanting to use this framework for a long time. It's specifically designed for the ESP32, and it's kind of aimed at like a high-level introduction to embedded programming. So here's some benefits. Not C++. All right? It's made for the ESP32, and it has Wi-Fi updatable functionality off the box. So like over the air, you can send your code to it. It's got a really high-level language. And Toit is actually a language in itself. So the people behind it decided we want something super efficient. We can't be using all this power or whatever. I don't know. They wanted to do some efficiency optimization. So they made their own programming language, which is kind of cursed, but you can deal with it. It has some benefits. So it's really hard to brick. For someone, a web developer like me, that's a really good thing. As I said, really power efficient. Shiny new technology. This is a huge one. I heard about this technology at a conference, which is how you know it's good. You're contractually obliged to use it if you hear about a conference, so I had to do it, and they have a nice logo. All right. This is some Toit code. Really basic. We're just initializing the pins that we connected. And then here's like our baby steps. So we want to be writing a pixel, and I have this function that writes a dot. You set whatever the pixel value you want, and then you just flip the clock up and down, and it writes into the first register. Once we've got pixel value in the registers, we can actually display it to the screen using the latch. So the latch goes up and down, and then whatever is in the registers shows immediately to the screen. So, art. This is kind of what that looks like. Wow. It's working. All right, so super basic. What we're doing is just full while loop. We're just writing dots, displaying the frame, and then going to sleep. And that's controlling our kind of framework, our frame rate. So not really what you'd expect, right? Like, you'd expect it to go left to right, top to bottom. That doesn't happen, unfortunately. But our goal is to make art. So how are we going to go from this convoluted pattern to actually displaying things that look interesting? Like, this is, it's a glorified snake game looking thing, but we want something better. Okay. Anyone recognize this picture? Okay. How about this one? Any nods? Ooh, it's a blur. How about this one? Right? Okay. I'm trying to show you the limitations we have on this screen. We're not going to have color. We're not going to have resolution. We're not even really going to have any contrast. Like, it's just black and white. So we're not going to be making this kind of cool, like, artwork, we're going to be making abstract art. Woo! Okay. So, geometric shapes, like interesting patterns, that kind of thing. Just setting some expectations here. But speaking of abstract, to make good art, we're going to have to get higher level. So right now we're working at a super low level, pushing individual pixels into the way it was flowing through the registers. That ain't going to cut it. We need some abstractions. We need to go higher. So the first thing I could think of was frames. We want to be able to define an entire frame for the board, define every pixel, and then just show it, okay? So kind of like this. This is like just an array, 256, because that's the resolution of the board. It's 16 by 16, even though it's like stretched, it's weird. But this is the size of our board, and then I've got like some pattern designated. So I want to show that to the screen. You could say, all right, well, let's just run through it, for loop 0 to 256, and then write whatever pixel is at the location. Well, this is what that looks like. Okay, it's worse than you think. Like, we're actually folding the bottom line on top of itself. This thing isn't a circle anymore. It's kind of stretched here. It's really bad. Like, this is not going to cut it for the Mona Lisa. So this is why that's happening. For each register, we're storing pixels, but they're localized in 4 places on the board. So we start here, head down, back around, go across, and then go down, and then go across. It's horrible. It's messed up. Here's what kind of happens, just to get this through why this is happening. We're not even writing to the next pixel. They're actually pushing each other down and around the board. It gets worse, yeah. Like, I couldn't really make a generalized, representation of what this is actually doing. I still can't really get my head around it. I was thinking, like, okay, maybe you can make a function that maps between the original frame and what the end one is. I tried. It doesn't work. The guy that made the other repository did this, so I copied him. This is a lookup table, essentially. We're basically saying, which pixels should you write first so they end up in the right order? If we want a pixel here, we have to look at a value that is at 0f, or like f0. So if you're not, okay, I wrote this in hexadecimal because I want everyone to think I'm cool, but you could just write it like in 0 to 256. It's the same deal. So this is basically saying 16 minus f. It's the end of the array. Basically, you need to write the end first in some kind of way. All right, so now that we've got that, and we look it up, oh my goodness, look at that. It's beautiful. Okay, this is the Mona Lisa. So we have that functionality, but like I don't want to rip off like Leonardo DiCaprio. Like, he's great, but let's make him something original. So this is a program I made, more of like a decorative thing using the frames. So it's kind of a bunch of different symbols, or some people say they look like ants, and then they move through the different frames, stopping to let you contemplate, appreciate the wonderful patterns. But it was not fun to make. This thing was absolutely handcrafted. I drew it in a pixel painting software, and then copied across in VS Code. It was awful. So we're still too low level. If anyone wants to make me like a script that can take a PNG and turn it into like an array, that'd be great. But I didn't do that. So here's what I think. This approach is very straightforward, writing the individual frames. You can do simple animations, and you can do a little bit of dynamic, branching. Do I show this or that? But it's super time-consuming. 4 out of 10. OK, abstraction 2. We're looking at cursors, or I guess paintbrush or something. Like, you store a position, and then you can move it around and turn pixels on or off depending on that. So this is like a more procedural way of interacting with frames. Here's kind of how the implementation looks. I'm storing an x and y. You could store an index if you wanted to. And then we're doing some manipulation of the frame itself, setting it to whatever you want. And you can flip as well. That's just really, really easy. We've got movement, so you can set it to a specific place, or you can move it in a direction, x and y. This is sideways, but you get the idea. So we're kind of picking a random point on each line, and then we're moving in a direction, flipping all across. So I like this one. It's not too flashy, but it does have cycles. So you will reach the end of the animation, and then it will form complete lines. So it kind of has some interest, but it's not too distracting. Really basic code. We're just storing where we start each time. We're choosing random positions on each line, and then we're just moving to the right, flipping it, and then going back to the start. That's what the modular is. And of course, going to sleep afterwards. Everyone needs a nice rest. Here's another one. This one is cells. OK, so anyone that wants to recommend I make the game of life, I hope this sates your fury. This is kind of like a expanding cells trying to go farther. Like they look for empty squares, and then they try and flip them. But the longer they look, longer it takes. I tried to do concurrency for this, but Toy and I guess a lot of microcontrollers, doing concurrency is kind of hard. They're very single-threaded. They kind of have to wait for the next person to go, and doing 4 things at the same time requires a lot of skill. But this is the code. So we choose a starting place for each cell, and then we're just setting the frame at the current cell and looking for a match until we find one. If we do find one, then we set it on, and then we break out of the loop. Otherwise, we choose an x or a y and go plus or minus in that direction, flipping the current pixel so you can see it moving around. It's kind of like you can see behind its thought process, and then at the end of the day, we're sleeping as well. OK, so this approach is pretty good. Like this is dynamic stuff. This is procedural. It's pretty simple. Like in essence, you can make really simple things all the way up to large scale, like really complex systems. But it's pretty hard to do large scale changes. So like you are just changing 1 pixel at a time. If you wanted to do like maybe a trail moving across, you would have to remember which pixels are on, and then like undo your progress afterwards. So we're still at a pretty low level, which is like imperative. We're telling it what it should do. No, we're telling it how it should do, and not what it should do. So a better way might be to say, I want a circle at this location, and then it already knows how to draw a circle at that location. So this is not like that. But it's still pretty good, 7 out of 10. So I have to give you tips and tricks. If you want to be doing kind of artwork of yourself, this is a bit different to the typical problem solving. If you want to make your own scuffed algorithms, here's how to do it. You think of like a basic rule. So start simple. This way you can really get started and see how it comes out pretty quickly. But we're really looking for those emergent patterns. So what I'm talking about is you take a rule, and you might add another rule. So like, let's say, go in a direction until you find an off pixel. And then you take another rule, like you only have so long to live, and you want to see your children again. So then those two rules will interact, and they will come up with a visual that is bigger than the sum of the parts. It's more interesting. And then you really have to experiment. So just keep trying. This is like really up to you how far you take this. I haven't gone too far with the actual algorithms. They're still fairly basic, as you saw, but that's how you kind of think about it. There's another point I want to touch on, the concept of a showcase versus a decoration. So I still think that the original animations that IKEA provided were much more of a showcase piece, something that you look at and you're like, wow, that's doing a thing, all right, that's cool, but it's not so much decoration. Like, you can't have that in your house. But showcases are cool. Like, if you wanted to make an artwork for a showcase, you would be approaching it in a very different way than an artwork for decoration. Okay, I think that's enough art. We're moving on to software. This is a software conference. Let's see how far we can push this thing. Okay, first, I'm gonna need some help. I'm just gonna put this here, but it's worth it. I'm telling you, it's worth it. I'll even give you a little, I'm gonna put this up like this. Everyone, is that working? Oh, okay. So I haven't exactly load tested this, but it is using edge functions. So if you came to Alexander's talk, this is an application of the edge. What's kind of going on here, it's still working, that's all right. You are on a device. This is also a device. So you're connecting to a server I set up. It's a Cloudflare worker that is then forwarding things onto a Cloudflare durable object. So a durable object is a different kind of serverless storage. It's kind of like key value, but it's aimed at really taking over, like giving state to applications. Stuff that you would make just throwaway objects. Now you can do that with a serverless context. So what we're doing is we're storing people's interactions, their current position. If you lift your finger off the phone, then it will undo those. And it's using a WebSocket to do that. The screen is also using a WebSocket, except the one flaw with this system is I use a push implementation. So anytime you send a request to my server, the durable object sends a request to this. Okay, so it works amazing if you have 10 people. If you have a crowd of 80 or however many you are, this thing is going to slow down. So I'm still looking at experimenting with some better architecture decisions. Hopefully, also, if you're on an iPhone, it works. Yeah, okay, cool. I had a situation where iPhones just were banned. They would send garbled messages to the server. And then yesterday, I tried it, and it worked. I don't know what changed. I think Cloudflare fixed their stuff. But anyway. So, Toit, this language that I had been using, what's the deal? So great things about it. Keeps it really high level. This is perfect for an introduction to embedded. The onboarding process is amazing. You can do over-the-air updates really easily. You don't really have to care about all these things like where does the random value come from, or how do I manage watchdog timers? I didn't know they were a thing, but it has some limitations. So I got the feeling that it really wasn't the right tool for the job. Toit is an IoT framework, so it's looking at low-power, long-running processes. I need as much power as I can get. This is graphical intensive. It's doing lots of computations. The higher the frame rate, the better kind of thing. So I got the feeling it was prioritizing efficiency over speed. All right, now limitations of the screen. So some of the limitations, we want to push past them, right? We've got a black and white screen. It's running a 16 by 16 grid. It's not really going to let us do much. But can we get past some of those limitations? OK, resolution, not really. It's 16 by 16. What are you going to do? Color? No. there's no way I'm going to be getting into the LEDs of this and adding a red, green, blue. Like, that's black and white. Okay, but contrast. Pixels are on and off, right? Well, they don't have to be. If you're familiar with electrical, you can do dimming and brightening, like, right? We can power them in different ways. And the reason I was clued into this was, this is the animation, this is a video I took in IKEA. These are half-bright pixels. Like, this thing is possible. So how do we do it? One approach would be pulse width modulation. So this is when you want to, essentially you can send like half the voltage to an LED, and it will be bright, but it will be like half as bright as the full power. But if you're using a digital signal, you can't really send half the voltage. It's either on or off. So what you can do is flicker this signal really fast in the proportion that you want it to send the power to, and the average voltage will be less because of that. The only problem is, this is a digital board, right? This is like ones and zeros going through registers. You know, my microcontrollers, data pins are digital. Like, everything is digital on this. So how are they doing this? Well, maybe they're just full send going as fast as possible. The frame rate is ridiculous. So the concept is you send through this frame, except for, say, we want it to be half brightness. These pixels would only be on for half of the frames, right? They're like subframes. So we need to be doing this. Say we want a pixel that is as third as bright. You would send on, off, off. And then you would send that as many times as you can, as fast as possible. So we got to go fast. Toy is not going to cut it, okay? So the speed you're trying to beat is either the response time of the human eye or the response time of the pixels, like how fast can they flicker. If it's too slow, then you're going to be in trouble. Okay. This is the part where I need cooperation. If you use the app now, it will glitch. So just, all right. But this is what we're talking about, right? This is Toy running as fast as possible. I'm just going to show that for a second. It's not fast enough. It's glitching like as far as like the second pixel. So not cool. The solution? Rust. All right. I bet you didn't think this was going to be a Rust talk, but here we go. So benefits, still not C++. Super speedy. It helps you write good code. Like the compiler is really, really helpful. Doesn't let you make those problems that C lets you stumble into. It is a low-level language, so this thing is going to be showing you some, exposing you to some pretty advanced concepts. It does have decent support for ESP32. So the company Espressif, they have provided their own libraries for Rust. You have to press the boot button a lot. I don't know if this is a problem for anyone else, but every time I run new code, I have to reach into this thing and press the boot button. I wired up a little contraption that helps me do it easier, but it wasn't ideal. It's also really intimidating for a little web developer like me, and I don't like the logo. So, time for a rewrite. This is last week. A lot of things had to go right for this to work out, but it did. So, time for not live coding, but live surgery. This thing is running Rust, so just bear with me for a second. The Rust process was, I'm going to turn it off first. That's a good idea. All right. So the Rust process was intense. Like I had a lot of help from my buddy ChatGPT, but I still almost couldn't get the thing to turn on. Everything was right. Like it was compiling, it was pushing, and then the screen just wouldn't turn on, and that was very sad. Turns out, when you have the enable pin, you think, oh, enabled high, right? Like on. I want to enable this thing. No, if you turn that enable pin high, it shows nothing. So that was my problem for a little while. Okay, so grand reveal. Please work. Whoa, crazy. Okay. This is not the best, this is not the most mind-blowing demonstration, but think about what's happening here. Like, we have 3 levels of brightness, and it's running without flickering, so this thing is going really fast. Forget 60 FPS. I haven't done the calculations, but at least 90. No. Thank you, though. Thank you for asking. So it cannot run Doom. It cannot run Crysis. I tried. Oh, I didn't try, but I tried running some pretty ambitious stuff. So if you've ever heard of noise gradients, Perlin noise, simplex noise, this is a way to achieve a smooth random distribution and then change it. I thought that would be really great. You have kind of flowing waves of brightness. This thing cannot handle it. I think someone please correct me, but math and especially division and floating point conversion to integer is really expensive. So as soon as you try and do any of those more involved computations, this thing slows down. It's actually a pretty good project for learning about optimization. Because if you do anything wrong, this thing just takes a beating and starts flashing at you. So you really know if you're on the right track. But some other potential, if we got some better, more powerful hardware in here, some potential options would be rasterization, right? So we take a circle of any size, and then we choose which pixels it should turn on. We can even add anti-aliasing to that, which kind of starts pushing in the resolution space. So we can start having half-bright pixels on the edge, making it look smoother. There's a lot of things we can do. But since this is a conference, I'm obligated to give you some key takeaways so you can feel good about sitting here for 45 minutes. So, embedded performance is complicated. I think I tried to start hitting this problem before I actually experienced it. So I was attempting to use the no standard version of Rust, which doesn't include a lot of those mathematics operators. It's a lot more difficult. I'm not sure if that would have helped. Making good art is really hard. So props to the IKEA guys. They did all right. They did pretty good. But it's not simple. It's not straightforward. You don't really know what you're going for when you start. What you make depends on the medium. So again, you got to really respect the boundaries that this has and work within them. So you're going to be getting better results by trying to think of things that would work on a pixel screen like the size of a favicon. This is really low resolution. It's 16 by 16. That's crazy. And then also, the last 20% of the project is super important. So for any project, really, I see people skimping on design, on style. That is what is going to sell your product and make it make sense in people's heads. So in the same way, I don't see this being a successful project with the 5 animations they have. But adding that extra effort and going to something that you can put in your living room or my bedroom, if you are on Teams calls with me, you'll see it, it can really make or break the project. And then also do stuff like this, right? This makes no sense. This doesn't solve a problem. This isn't a tool. But it's a lot of fun. And I guess you can call it learning if nothing else. So if you want to try this for yourself, there'll be an affiliate link in my... No, I'm kidding. But IKEA, please collab. Expect the unlimited edition, $12.99. It's a steal coming to you next year. Thank you very much.
Now we have time for a few questions, one hand at a time, and give me time to run all the way around.
Great talk, by the way.
Thank you.
Just wondering if you've got any thoughts on other tools like Zig versus Rust at all.
Zig versus Rust?
Yeah. Would you do the same thing with Zig, or what was the reason for picking Rust over that?
So
maybe?
I guess if we're talking frameworks, languages, libraries, I don't know Rust, right? But I want to know Rust. Something about it speaks to me. So I think that was one of my motivations for doing in a specific language. And same thing with Toy, right? I knew I wanted to use Toy and the ESP32 before I knew what project I was using them on. So that's a terrible, you don't go to your work and do that. Like, you should always weigh the pros and cons before you start learning something or using something. But that's how I approached it. Anyone else? Yeah, so I'll be setting this up somewhere, probably in the Bankwest area later on. If you want to see any of the extra modes I made, please come and have a chat. It should be really fun. Got another question?
Hey, the way that you've wired it all up, would there be a possibility of, say, doing getting 4 of those frames and doing it
100%.
So you can have 32 by 32 display?
Yeah, I did the math to get a 1080p monitor. I think it's about 1 kilometer. I think you need several hundred meters of these screens. But yes, it's 100% possible. Not sure about power draw, that kind of thing. But each module has its own power cable. So if you had a lot of USB ports, you could. And also, props to the IKEA guys, they made a modular system. Whether they wanted people to break into it or not, I don't know. But it's a good layout. Yeah. Cool.
Any other questions for Drew?
Yay.
Sorry, I'm just curious. Did you at all try and attempt to control the dot in real time with your phone or something like that?
Yes. Yeah. So it works better with one person using it at a time. But that's essentially what the demo for the phone was. You can swipe around. It is real time if it's not ridiculously laggy. But this is probably a good application for a distributed game, right? You can have a group of people, maybe doing voting. All right, everyone to the top of the screen if they want to learn Rust, and then or you could have some kind of game, right? I think it's a nice format to have a central point of attention, and then a lot of people controlling it. Oh, and this is global as well. So if this is in my room, you can go onto that website and make pixels show up. I'm going to be shutting that down immediately after this conference though. Cool. Well, if that's everything, feel free to check out the repositories, leave any meanly worded PRs, help me learn Rust. Definitely keen to talk to you guys if you have any experience on these kind of topics. Thank you very much.